Assalamu alaikum. This is Imran Khan, and today I am going to show you about the diffraction pattern, a basic, and Rayleighs criterion. It's an important question asked in the 12th board exam. So I welcome you to my channel. I learn physics, and without wasting more of your time, let's start. So we have seen what is diffraction in our last lectures. Okay, now here what is diffraction? I tried you to imagine the diffraction pattern. Actually, how is the diffraction pattern? I would like to show you directly. See, this is the diffraction pattern. If you search on Google, you will see images like this. So this is diffraction pattern. In this, if you zoom it, you will see the diffraction pattern on the screen like this. In the center you will have the maximum brightest point. Okay, after that you will have the dark ring. Can you see that? After that you will have the bright ring. After that you will have the dark ring. After that you will have the bright ring. Okay, now what is interesting here, the intensity goes on decreasing. You see, here the intensity is maximum, here it's minimum, again here it's minimum, again here it's minimum. Intensity goes on decreasing. The size of the dark ring and bright ring are different. This is wider, dark ring is smaller. And the central bright point is the brightest point in whole scenario. Did you see that? So this is diffraction pattern. Now here, if you plot the graph between intensity, then you will see something like this. Like this. If you plot a graph with the distance, then you will see the intensity is maximum here. Okay, intensity is maximum here, and it is getting minimum because here is the dark point, here is the bright point, here, but with less intensity. Here is the dark point again, here is the bright point, but with less intensity. Here is dark again, here is bright. So brightness is decreasing. If we plot the graph, the graph will be look like this according to intensity. So here I give you what is the name. We can see it is like this. Now here this is first minimum, this is second minimum, this is central max, this is secondary max, directly secondary maximum, this is third maximum. What we are going to show, what we are learning in Rayleighs criterion. So today's topic is Rayleighs criterion. Now I'm going to start. First of all, I give you 2-point object. For example, there are two LEDs. First, understand the concept. There are two LEDs. These two LEDs, if I place close to you, you can see there is distance between them. Yes, there is distance between them. They are distinct objects. But if I take that pair of LEDs away from you, it will be difficult for you to distinct between them. They are one or they are separated. If I take away from you, far away from you, then you cannot say they are two even. You will say there is one source of light. Same like that, if you have the two sources of light, their diffraction pattern on the screen also will be overlapped. So how it will be overlap, that we are going to see. So in Rayleighs criterion, we are going to Rayleighs criterion. We are going to study this. First of all, for the did you understand the concept? Yes. First of all, I would like to clear some basic limit of resolution. Limit of resolution. After that, power of microscope. These two things you have to clear. What is limit of resolution? Resolution means they are distinct. You can see they are distinct. What is the limit? What you are using? Microscope. So if you have 2-point object, now leave the sources of light. Let's consider 2-point objects. There are 2-point objects. If you are seeing with the help of microscope, and you can see them distinct, so there is difference, there must be the difference between them. That difference at which, the distance at which you will be able to see they are distinct, that distance is called as limit of resolution. After, if the distance again decrease, it will look it is 1, not 2. So what is the limit of resolution? It is the distance. Okay, it is the distance between 2-point objects at which or at this distance we are able to see objects are distinct. This small distance is called as limit of resolution. And if you, for example, it is d, suppose, and if you make the inverse of that, inverse of limit of resolution is called as power of microscope, resolving power of microscope. You can say it is a resolving power of microscope. So 1 by d will be power. Okay, now let's continue our topic. Here, these 2 points object I can represent in 3 ways: just separated, well separated, or not separated. In other language, in other words, we can say just resolved, well resolved, and not resolved. So let me see just resolved. First condition, just resolved. When you can say it is just resolved? For this, you have to understand what I am saying. First source of light, first diffraction, that graph is here. Now concentrate what I am saying. What is this? Central brightest point position. What is this? First minimum. Central bright point. And what is this? First minimum. With this distance, we have to compare. We have to compare what? We have to compare the distance which is in which overlapping is taking place. When it will be just resolved. For example, this is the graph for first point object. So let I draw. This is the graph for first point object. There is second point object, diffraction take place. I draw up the graph, and the graph comes on the same page. It's like this. This one just resolved is based on overlapping. Well resolved and not resolved based on the comparison between the distance. How? I'll show you. Now we will look for just resolved. So consider this is here. This is the diffraction pattern wavelength graph for first point object, and this is second graph for second point object. Why I draw like this? How can I know? Because I know the key. Where is the key? This is the key. Did you see that? Suppose this is first and this is second. So what's going on here? What is this point? First minimum of first point object. What is this point? Central maximum of second point object. If you interchange, it will be same. First, this is second. First central maximum of first point object. What is this? First minimum of second point object. What they are doing? They are overlapping. Did you see that? So we can write the condition for just resolve. If the central bright point of first diffraction pattern or point object is overlapping on the first minimum of second point object, then this is said to be just resolved. Okay, what they are doing, I am writing here only. What is this? Central bright point of first point object is overlapping on first minimum of second point object, then this is said to be just resolved. Now we will look second for well resolved. Now here we have, for example, this is first, already ready-made first. This is the diffraction pattern in terms of graphical representation for first point object. Okay, that's it. You know what is this and you know what is this. Now where I am drawing, just know why I am drawing like this. I will tell you. This is the graphical representation for second. You should know how it goes. Just I will simply, I will remember this point and I will do it simply. Not bothering about where this is going and where is this meeting. It should be same like this. Now what's going on? This distance you compare and central points of the two. This distance you compare. What is this? Central bright point of first wave. What is this? Central bright point of second wave. Isn't it? What is this? Central bright point of first wave. What is this? Central point, bright point, first minimum of first wave. Keep in mind, please, only these names, that's it. The distance between central bright point of the first wave and first minimum of first wave, if it is less than the distance between central bright points of the both waves or central bright points of the both diffraction patterns or central bright points of the both point objects. Okay, just we are comparing the distance. What is this? This distance and this distance. So this green is the distance between central bright point of first and first minimum of that wave. This is some distance and this is some distance. What is that some distance? Distance between two central bright points together of both. If this distance is greater If this distance is greater than this distance, then we will say this is well resolved. So speak with me. If the distance between two central bright points of the both waves is greater than distance between central bright point of the first wave and first minimum of the first wave, then it is said to be well resolved. And when we will say not resolved, look at it, look at that. Here I'm gonna make another, that is number 3. I will say not resolved. What will be happen in not resolved? We have to make this distance less than this distance. Did you know the key now? Now you know how to draw. I'm not gonna draw. I have to draw, but you have to cooperate. For example, this is the diagram. First minimum, second minimum, this is central bright point. Central bright point. We have this distance to compare, isn't it? Okay. Somewhere here I have to draw the central bright point of another wave, isn't it? For example, I take here less than it. Wherever you take, I will take here. So it will come somewhat here. Okay, because I want less distance between two central bright points, and you will notice it. Look this distance and look this distance. Isn't it smaller than this one? Yes. So I will draw another one. I will draw like this. I know how to draw. Don't care where it's going. Wherever you go, I don't know. The one who is taking your paper, he will look for this point. So here what you will say, the distance between two central bright points of both the waves or both the diffraction patterns is less than what? What is this? Central bright point. What is this? First minimum. Then central bright point and first minimum of first wave, to whom we are comparing with. Wave, or you say diffraction pattern, or you say point object, anything. If it is less than this, it is not resolved. If it is greater than this, here we should write greater than. Then it is well resolved. And if it is it's about overlapping this point and this point, this is just resolved. So this is all about Rayleighs criterion. I hope you got this, and here itself you can try and remember up to exam. So it's simple. It's just about comparing the distance between what? Central bright point, both of the central bright points, and one's central bright point and first minimum. That's it. It's simple. So this is all about Rayleighs criterion. Assalamu alaikum.